Hi and welcome to another mini lecture on pre-calculus. Today's lecture is about trigonometric functions and special angles, problem type 2. So let me tell you of two ways of going about the problem. So what are the type of problems you have here? Some trig functions are being mentioned, for example secant, and applied to an angle. The angle is a special angle, meaning it's either a multiple of 30 or 45 degrees. So all the questions in this section are in terms of degrees, so I've chosen a few of these things to take a look at. Two ways of going about this thing is either you use that unit circle graph you see in your textbook. So while you were going through the lectures, you come across a picture of a unit circle. The angles on the unit circle are labeled, so 0, 90, 180, and then of course you have 270, and then by the time you come back you are at 360 degrees. Going halfway you have your 45, and then 135, and then 225, and then of course you have 315 degrees, and then you have multiples of 30, so you have 30 and 60, and then 120, 150, 210, and 240, then you have 300 and 330. So for any of these points, the x, y coordinates are written, so you come across a rather crowded picture with all these angles, and at each angle you have some x, y coordinate. Is that right? The assumption being that radius in all cases is 1. This is a unit circle. So previously we said that cosine of theta is just same as x, sine of theta is same as just y, tangent of theta, now you have to actually do a division, it's y over x, and then secant of theta was 1 over x, cosecant of theta was 1 over y, and cotangent of theta was x over y. So faced with any of these questions, you can go ahead and consult the graph that you have for this. So I recommend you redraw one in your notebook, label it however is convenient for you, and then use it in connection with these functions. So for sine and cosine it will be straightforward because you're just reading the coordinates. For the rest of them you have to actually take some ratios to figure it out. But I believe it could be somewhat daunting to go through that process, not easy to memorize perhaps. What is easier to memorize is perhaps going through triangles. Triangles, we said, well, we essentially have two types of triangles here. Either you have a 45 degree triangle, so 45 degree, then to keep the same radius and not to change that, I will write this as 1, and this side would be radical 2 over 2, and this side is also radical 2 over 2. These two numbers are like coordinates of this point 45 degrees. And then in case you have learned from high school to think about these functions in terms of ratio of two sides, well, then you can easily find whatever ratio you need. So in this case, well, we know cosine of theta, cosine of any angle is the ratio of adjacent to hypotenuse, or sine of it is ratio of opposite to hypotenuse. So you can find required quantities. How about the other angles? So the other angle that we need to know about is the 30-degree triangle. So if this is 30 degrees and you want to keep this one to be 1, this will be a half, and this will be radical 3/2. There is a sibling of this thing, which is the same triangle turned sideways. So if you have 60 degrees, so this is really that 60 degrees angle, so this side will be radical 1/2, and this one is radical 3/2, and this one is just 1. So again, any of these questions that we are facing, you can either go back to your table, find all the numbers, and do the required ratios, or adjust the problem so that it'll be one of these triangles, and then you'll be all done. Previously we had also mentioned that there are some extreme triangles, like if you want to have angle of 0, how would you handle that? Well, 0 means the triangle has collapsed, but we're just going to kind of open it up. So this, we pretend it is 0 degrees. This side is 1, this side is 1, and that side is 0. Same concept applies if you have this in vertical direction. In that case, the angle is 90 degrees. This is 0, this is 1, and this is 1. So again, to visualize these extreme angles, we have to kind of kick the triangle open so that we can see what's going on. Okay, secant of 315. How do we go about this? Let's do it both ways. 315, so in your picture you have to go to this location. So you probably have this picture drawn in front of you. First of all, you locate where you are at. So if I am 315 degrees, this one, the coordinates on your picture is going to be what? Radical 2/2 and minus radical 2/2. Is that right? That's probably what you're going to see in your diagram. And you want secant. So this is x, this is y, and secant is what? Secant is 1/x. So secant of this, secant of 315 is going to be reciprocal 1/that. Well, let's clean it up. I multiply by 2, it becomes 2/radical 2. Multiply by another radical 2, this simplifies to radical 2. You remember the topic of rationalization. So we get that answer to be radical 2. Okay, what if from high school you're used to this style of doing things? How do I handle that issue? I'm going to take this triangle, so let's call this the 45-degree triangle here, plant it where I need it. So where do I need this thing? Let's I want to be at this 350 degrees. Let me draw this thing in. Put this triangle here. Okay. Well, if you try to take the triangle, turn it upside down, just remember this is radical 2/2. That one goes into the negative, becomes minus radical 2/2. So this angle is 315 degrees. And this is your 1. Now you are looking for secant of 315 degrees. This is still playing the role of your adjacent. What was 315? It was 1, which is hypotenuse. Let's call it hypotenuse over adjacent. So hypotenuse is 1, adjacent radical 2/2, and same action as before, we get radical 2. How about tangent of 315 degrees? So you remember What was tangent? Let's write it here. Tangent of 315 degrees. Tangent of theta was always the ratio of y over x. Is that right? Tangent, here's our tangent formula. It's y over x, and that is what we are going to do here. So what is our y? Our y is minus radical 2 over 2, and our x is radical 2 over 2, and they simplify to just minus 1. Is that right? You are performing the same thing here, really, exactly same set of operation, except that when it comes to issue of memorization, all that you are memorizing really two triangles. There is that one and there is this one, really. If you want to push it, you can say this is different, but that's really same as the other triangle. So in this case, we are memorizing these triangles, and then we put them in the correct quadrant and assign plus or minus to the sides accordingly. Let's go practice another one. Secant of 360 degrees. So where is 360 degrees? 360 degrees, well, I've come back at this point. So this is 360. I have come back to this corner of the circle. What are the coordinates of that? Coordinates of this thing is really, well, x of it is 1. What is y of it? Y of it is 0. So if I want secant, it's going to be ratio of secant of our angle was 1 over x. Remember, secant was 1 over x. 1 over x. So what is our x? Our x is just 1. That ratio just becomes 1. So this is 1. How about tangent? Tangent of our angle was a ratio of y to x. So y is 0, x is 1, and ratio is 0. Well, how about the triangle version? The triangle version, the picture that we have is really one of these extreme cases like this one. So we said we are, this is a collapsed triangle, so this angle here is really 0. So, okay, so when you do 360, by the time you come back, the angle you're dealing with just angle 0. And these sides are 1, 1, and 0. So what is secant? Ratio adjacent, here's adjacent, to hypotenuse, which is 1, and that ratio is just 1 over 1 again, and it is just 1. How about tangent? Tangent is a ratio of the opposite. Here's my opposite, here's my adjacent, and the ratio of them is 0 to 1. It is again 0. So cosecant of 45, well, what was cosecant? Cosecant of an angle was, that was the reciprocal of sine, is that right? So 1 over y. And well, where is 45 degrees? 45 degrees, of course, that's the easiest. 45 degree. The coordinates you see on your picture, radical 2 over 2 and radical 2 over 2. So if I, then this is x, and of course this is the y. So 1 over y value, 1 over y value becomes 2 over radical 2. We multiply by another radical 2, and that is the answer. How about cotangent? Cotangent of an angle. What was that? Remember, cotangent x over y. In this case, we can hardly go wrong with it. X over y, the ratio of these two is the same number, so the ratio will be just 1. For the first quadrant you really need to memorize those answers. What else do we have here? It's like cosecant of 60. Well, in this case there isn't really much to say with respect to the triangle problem. That's exactly what we started with. We said you have radical 2 over 2, radical 2 over 2, and 1, and cosecant will be the ratio of hypotenuse, so that's the 1, to the opposite, which is radical 2 over 2, so 1 over radical 2 over 2 is just radical 2. Cotangent is the ratio adjacent to the opposite, and that's again 1. Cosecant of 60 degrees. So in this case we have a picture where our angle is 60 degrees, and the coordinate of this location, the coordinates would have been 1/2 and radical 3 over 2. So again, you draw your circle with the numbers attached to it. You make your table, but find a way to understand what's going on so that you can answer the question in the middle of a discussion, so that you don't need to go and look up a piece of paper or a calculator. Okay, cosecant of an angle. What was that? That was 1 over sine or 1 over y. That was definition of cosecant. Cosecant here. Cosecant was 1 over y. Then, well, what's our y? This is x. This is y. So that would be radical. Excuse me. 1 over radical 3 over 2. You multiply by 2 in the numerator and denominator. If you want to simplify it, you multiply by radical 3 perhaps, or you leave it as it is. Either way, software will be okay with all these 3 versions. These are all good. Excuse me here. Well, this is not good. This is 2 radical 3 over 3. So here is rationalized answer. Perhaps the cleanest one was just the one in the middle because we wrote less. How about cotangent? Cotangent of theta was a ratio of x to y. In this case, x is 1/2, y is radical 3 over 2, and the ratio becomes 1 over radical 3. If you want to rationalize, you can write it as radical 3 over 3. Either one is fine. Okay, so what did we mention? We had the angles in degrees around the circle. These are all the so-called special angles. What angles become special? That's a very nice story in mathematics. There are other angles that are special, so that is something that you can go and search and see what are the angles for which we can write an answer in this style, like with square roots and such, or fractions. We can write the exact value. Of course, any angle you can pick, you can type it on a calculator and it gives you a decimal approximation. That's another issue that you're going to see in calculus 2. Where do those numbers come from? But for the so-called special angles, there is a interesting story of it in mathematics if you want to pursue that. So we said there are 2 ways of doing this thing. This is so-called circle trigonometry. This is referred to as circle trigonometry. It's possible that in high school you went through another version of it, sometimes referred to as triangle trigonometry. And I just want to say that these are same things. Whatever works for you, is fine. Okay, until next lecture, good luck